This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
We're very pleased today to have an Institute for Energy Efficiency leadership lecture. I'm John Bowers, Director of the Institute for Energy Efficiency, and we've had a number of these over the years, and great speakers and well attended. And as I think you know, there are 6 group areas for the Institute, and buildings is one of them, and perhaps buildings is the most important one in the sense that buildings use up 40% of the energy in the United States. So the other 5 take up less than that. So we're very pleased today to have a topic that's very important and one that I think affects certainly all of commercial industry and universities as well as our own residential. So I'm very pleased to introduce Igor Mezek. Igor is a professor of mechanical engineering, and he runs the solution group that's focused on building efficiency. And they've had a lot of advances, and they've had some very interesting roundtables with lots of software companies coming and talking about how to more effectively manage buildings. So he's done a great job at that. And so without further ado, Igor Mezek.
So thank you, John. It's my honor and privilege to introduce our guest today. Our guest is Gerald Smith. He now is the director of the facilities and energy at Microsoft, but also has another role. He's the global sustainability energy manager for Microsoft as well. He spent time at Cisco doing a very similar role, and earlier in his past, he was just up from here at San Luis Obispo, where he got all his degrees. Now, Daryl and I met when I visited the Microsoft campus just some months ago, and I can tell you that it's really quite impressive what they have done with the aspects of smart buildings in their own facilities. Also, there is a full lab of testing, so if you are a company that actually wants to go in and test something, Daryl is going to kindly right away do that, but you might wait for the good news or the bad news. You don't know what's exactly going to come out. He knows pretty much everything in this space. He was the keynote speaker at Caltech's Energy Forum just a couple of months ago. And it's, as I said, my honor and privilege to have him here and give us a talk on smart buildings or buildings with a brain. Daryl.
Very much. Thank you very much, Igor. It's great to be here, and I'm honored to be here. And this is a very interesting topic, and so my objective is to really take you through a journey, excuse me, of what we've done over the last couple of years and how we're driving energy efficiency at city scale using data, and that's really the fundamentals. So I think the one thing I did want to show is, so Microsoft is carbon neutral. We've been carbon neutral since our fiscal year 13, and we have, these are our pillars of being lean, be green, be accountable. And this is real important. I'll show you why in a minute. So under each of these pillars are our tactics. The ones that I focus on the most is we actually charge a carbon fee at Microsoft. So if you have travel, if you have buildings, or if you travel, you have buildings, you actually assess a fee. That fee helps me make investments in energy sustainable projects around the world. The other thing is what are we doing around our buildings? How are we setting goals and targets? And I think the most important thing about this slide here is the architect of it. Her name is TJ DiCaprio, who oversees our carbon neutrality. She's an alum of UCSB and asked that I mention her work. So maybe she's going to be a future speaker here. So let's get down to really about the campus in Microsoft. So our Puget Sound campus is 145 structures, 15 million square feet, and about 59,000 housed heads. It's one of the largest contiguous corporate campuses in the world. And there's a lot of data up here, but there's a couple really good points. is one, we have multiple disparate building systems. So the way that Microsoft grew was over a number of decades, there was phenomenal growth, and there was at one point 3 people in every office. So there's pressure on the real estate team to deliver space. So we had developers building buildings, we were building greenfields, and while we were building to the energy efficient standards of the time, we didn't have a binder that says, all right, if you're going to build a Microsoft building, here's the specification, here's the design standards, here's all the content you'd need to know how to build a Microsoft building. So contractors did what you do when you're pressured to deliver as quickly. You went to the first manufacturer, and if they couldn't deliver the space, you went to another. So an outcome of that is you asked me, what manufacturers do we have? What type of building design? What type of building control systems? My answer is yes, we have it all. And it's very hard to manage a campus this scale with all this different disparity. And we're no different than, say, a city. We're a small city, but a city nonetheless. So we have a lot of disparity, and it's very causing a lot of waste for us. So the other issue is we have a lot of data. So across our portfolio, we collect 500 million data transactions every 24 hours. And up until recently, we had done absolutely nothing with that wealth of data. We overrode it, we deleted it, and there really was not a way for us to harness this. So we have a lot of disparity and a lot of data. And that really was our jumping off point. So we ran around the world, we talked to technology peers, we talked to national labs, universities, with this concept of how do you drive energy efficiency with data you have? How are you doing it? How are others doing it? And the theme that came out of it, and now a dear friend at HP says, it sounds like an interesting concept. Let us know when you figure it out. So there wasn't anything I could point to say, they've got it, they're the beacon, we'll follow them. And so, as you probably understand, this isn't a Microsoft problem. This is an industry problem. The construction industry has been building buildings the same way for the last 30 plus years. Everything built in silos. So for our campus, if I make a change to our mechanical systems, say I want to change a 2-degree set point across the entire campus, mind you, it'd take me several days to do it, but I don't know, did I just improve energy efficiency? Did I degrade it? All our power monitoring, all the data, the rich data of all our energy is in another application, another tool. So it takes hours and hours to build this. And I would say that my team, my engineers at Microsoft, 80% of our time was spent as analysts, going through spreadsheets, putting data loggers on, and really compiling data. 20% of our time, we were really engineers. And there's a pretty big problem with that. So we said, this is definitely something we have to address. There were 2 ways to go about this. One, we could rip out all the existing systems, all the different manufacturers we had, all the different controllers, and replace it with one. There were 2 problems. First is, I wouldn't get some of the capabilities I was striving for, and the second, it was $70 million. And so it didn't make a financial sense. And real estate sits in finance. That's where we report. So we think of everything really anchored in ROI. And it just wasn't feasible. Plus, I had to have building shutdowns, lab shutdowns, and I'm sure it's similar to labs within universities, that if I asked for a shutdown in the lab, they said, well, how does 2024 sound? So it just wasn't going to happen. The other approach was, what if I could take data from all these existing systems, applications, and use that data and take it to a common platform? And that's the approach that we took. So you think of our situation, we have disparate systems, applications. I can't look at one building to the next. I can't compare system to system, even built in the similar year, because to get that data out is very, very time consuming. So we have a lot of challenge with that. Also, we do a quarterly lab report. We pull all the energy meters across the entire campus of every lab, and that takes about 80 hours. That's why we call it the quarterly lab report, not the monthly lab report, because it's just too long to do it. And so that was a lot of the churn. Honestly, and this is embarrassing to say, we had a clipboard budget. We were actually walking around some of our key things with clipboards, and let me remind you, we are Microsoft. We're using clipboards. It's not the tablet that we want to be with. So So that was the situation. So we started with as everyone else does, a procurement activity. So we started with 56 vendors around the world, got down to 6 for an RFP, and then we did a 3-vendor pilot for a year. And so we looked at, our pilot actually was the same area as the Empire State Building. So it's about 2.6 million square feet. So you got old buildings, new buildings, different systems. And that way the vendors over the course of this year would be able to tell us, we could prove that they could actually execute on what they say. And it was difficult for my team because I did not allow anybody to take a vacation, get sick, or leave early. So I would have never wished this on anybody. So if you're ever going to do a pilot for a year, maybe 2 vendors is good. So anyway, and then everything that our objective was reduce our energy consumption. That was what the core of what we're trying to do. But we also wanted to optimize the building assets. Look, we own most of our own buildings in Redmond, so we own about $4 billion of assets. If I can extend the lives of these assets, that's real dollars. And then the third thing is we want to improve labor efficiencies. My nemesis is windshield time. And the windshield time is really you get a call, you go look at the issue, you go to the parts house, go back, make the repairs. All this waste, all this movement is muda. How do you do that more effectively? So the 3 approaches we took were fault detection, energy management, and alarm management. Fault detection is where the money's at, and I actually underestimated the value of that considerably when we started. And fault detection's been around a long time. It's nothing new. We just haven't seen it applied in buildings. And so just to give you, what's the difference between a building fault and a building alarm, let me use a medical analogy. With a building alarm, you're in the hospital, you're in the emergency room, you're too late. Something has happened and it's failed. With a building fault, it's as if your physician's telling you, well, your cholesterol's rising, your blood pressure's increasing. It's a precursor to catastrophic failure. And we look for 2 different things. When equipment's not running as designed, or when someone's made a set point outside our standard. If any of those 2 occur, we want to see it. And then the other thing is really being able to manage your energy consumption. So we basically, before this, were managing our energy from the utility bill. So I could tell you something that happened 60 days ago, but by then it's too late. And how do you react? I'll show you really what the benefits of that. So these were our approaches. But because fault detection is so important and it is changing the way we manage our buildings, I want to give you a little scenario. So this is a 30,000 CFM air handler, the big box on the roof, or 85-ton unit. And I've been doing facilities management for close to 20 years. And there's 2 different modes in facility management. Either everything is fantastic or our hair is on fire. There's really no middle ground. I'm not sure yet why. So we're in the building, we're having our meeting, we're doing our work, and all of a sudden we have something go into alarm, and it's dumping cold air into space, and we're bleeding energy, and we're in our trucks, and we're running, we're going, and we make that diving catch. And this diving catch is what we're used to. That's how you ask anybody that does facilities, that's our normal MO. Why? Why does that have to be it? And I argue it's not. So really with fault detection, we actually can see when assets start to degrade. So for this example, it's 71 degrees in the space. So none of the people in the building know there's an issue. And I need to preface this by saying I have 59,000 living sensors in our campus. Those are employees calling saying, I'm hot, I cold, I hear noise. I don't want our employees to be sensors. So we can see as stuff starts to degrade, and we can actually decide at what moment do we want to respond. Do we add something to the work order? Do we actually go respond? Is it critical? And if we do nothing, we're in the same boat we were before. So what's very interesting is we've added no meters, no sensors, no hardware. This is a completely software play. We're taking the data, and for this example, this is a 300 CFM thermal unit. It's probably what's above our head providing the cool air. This is a very small unit. We have ones that are much, much larger. But the point is, this is how it came from the factory. We did add the plexiglass, I should say. But basically, all the components is how it came. And that data is what we use to command and control it. Turn dampers on, off, turn the resistive heater on, off. And so that's the data that I talk about that we've had. We're actually using that data to tell us what the equipment's doing, How's it performing? And that's really an interesting way, because this is a capability we just didn't have before. And I should say that we have 45,000 assets we maintain. So that's a couple things. So from a fault detection standpoint, think of it this way. I'm casting a net across the entire campus to tell me what every piece of equipment is doing. And so we have a fault rule, and I have about 225 fault rules that scale roughly 45,000 assets. So fault rule is, what are we looking for? What's the condition of the equipment that we want to see? And then I have the points. So what points do I need, say from the building automation system or maybe another system? And what's the syntax? So we actually write this ourselves. It's if then else statements. That's all we're doing. You know, if I'm running the air conditioner and the front door and the front window's open, tell me. It's in essence what it is. But here's the really cool part. Not only can I tell you what's not working as designed, I can tell you how much it's costing in wasted energy. So we can actually prioritize on energy waste. This is our fault rules here. An important part here is this is, you know, what we're looking for, the class, but if the ones up in the boxes, that's a pseudocode. That's a if then else statements. And actually we have duration. So it's really important when you're looking at fault detection to understand duration, because if you look at and you flag everything that's in fault without a duration, then everything's broken. You catch transits, you catch everything, and you'll go crazy. So some things we are looking at every 1 second, some things we're looking at every 15 minutes, some things we're looking at every once a week. That's the frequency or duration we look at. And then we added the two columns at the end. What's the possible causes? What's the possible solutions? Because we want the people in the field, the ones that are working on this, to know what to do. So this is just an example of one of the buildings we connected to. So this is a LEED silver building, and I'm a fan of LEED, USGBC LEED. It's really helped the industry. And this is a brand new building, or it's been in operation for a year. We identified roughly 17% energy saves in just a couple weeks. And, you know, really, it was shocking to have a LEED building, because the plaque looks great. And so, of course, somebody's got to be wrong, because it's a LEED building. How could it be inefficient? And it really comes down to a couple things. One, buildings aren't energy efficient unless they're operated efficiently, first and foremost. Second thing is commissioning, and we hire a third-party commissioning agent to do commissioning our buildings. Doesn't go very wide, doesn't go very deep. And so coupled with that, and so here's just real 3 examples. The outside damper was stuck that brings the cold air into the building. So that free cooling, and we have a lot of that, a lot of hours in Seattle. The building automation system says, hey, you're cooling, it's wonderful, you're using all that outside air, but we really weren't. The dampers were all closed, the combiners were all closed, and we're running every compressor in this building. So that's where how do you find that if you only have one thing telling you? And the other thing is, we had a problem with the sewer pump in the basement. This building has 4-level car park. And so we put all the garage exhaust fan in manual while we made the repairs. That was about a year ago. That was about $60,000 ago. Nobody realized it was left in manual. So that's an example of catching something where set point's been made outside our standard. The other ones where something's not running as designed. So our energy manager, who looks at all the energy consumption for the US, goes through and looks for different elements. And if you look at this graph, and I took the axes off on purpose, you see maybe, okay, this building's running 7 days a week, have a quick moment to look at it, I don't see any weird, so pass it, paint on, everything's fine. The problem is, if you see that little peak, that's Wednesday at noon. If you follow that peak over, that's Thursday at noon, Friday at noon, those flat lines are Saturday, Sunday. The peak you're seeing there is actually occurring at midnight. So we're hitting a 900 kW peak at midnight. And of course you're going, what the heck could cause a whole building to go to, especially this building, to go to 900 kW? The only way it could do that is if all the heaters in the entire building were on. Guess what? There was a code error in the building automation system that told that building to go to 80 degrees every day at midnight. And it has been doing that for 7 months. So, and it probably could have been doing it for another month. So being able to catch things like that. And so really, when you think about data, you know, if you give me the annual energy consumption of the building, and you give me 12 months worth of weather, I can tell you a ton about a building. This is our California campus. I can tell you seasonal variation. I can tell you if you're economizing. I can tell you a lot. But if we connect and can see that data in real time, what can we really tell you? So this campus, we connected in November of last year. So just a couple months ago, we found $240,000 of energy saves in 30 days. That, by the way, paid for the software and deployment. Go team. And so the percentage you see on each item is the percentage of that $240,000 that we found. And it's interesting that the HVAC setback, basically somebody coming in and say, hey, I need to run this room, this conference room, this building over here for the next 3 weeks, 24/7. And nobody caught that was been that way for the last 6 months, year. So it was interesting that was such a big find, but it was, look, we have very talented people running this building. PG&E had audited this building and couldn't find any issues whatsoever. But we were running the boiler at 190 degrees year-round, and this is down in Silicon Valley. And so the biggest point here is the phone wasn't ringing. The people in the building, the facilities team said, we're doing a great job. Nobody's calling, nobody's complaining. But what is happening is the air handlers are pushing air in at 55 degrees, and right before the air got to the space, the heaters, and we're hot water fed, the heaters warmed up the air. And it was doing this in the middle of summer. So, hey, why not turn off the heater and just bring the air in a little bit warmer? In essence, that's what that was, and that was a huge savings. So again, just because the phone isn't ringing doesn't mean the building's really optimized, and that's a really important finding for us. So I want to give you a couple pictures of before, and this is our corporate campus before. So this is one of our building automation systems. We have several. Oh, why would you want just one? If you see all those colors across all the buildings, those colors mean absolutely nothing. I can't tell how much energy we're using, what buildings are in distress, which buildings are running well. It's just a very simple building, or a simple map. And so if I click on one of the buildings, well, you're in the wrong application, you're in the wrong system. It's very cumbersome. So if we have a power bump or a windstorm, and we tend to get those in the Pacific Northwest, we roll trucks. We actually drive around those campuses, our lights on, you hear the generator, go to the next campus, as we're diving into systems as well. If you give me about 5 to 6 hours after any pretty good sized power bump, I'll tell you the condition of the campus. But 5 to 6 hours is an awful long time. So that's one of our pains. The other one is when it's above a design degree at our campus, and it does get in the close to hundreds in Redmond, we take screenshots of the chillers, air handlers, pump, our mechanical equipment. And these screen captures, the screenshots, those are our engineering data in winter. So we actually are going through screen captures is how we do our engineering. That's just one step above clipboards in my mind. So that's, again, we're Microsoft. So that was the before. That was painful. So this is the after. So this is one of our dashboards. This is our executive dashboard. And I'm doing much better because I used to get a lot more emotional. But this is every building automation system, every power meter, every lighting control on one screen. The orange is energy, the blue line is weather. I know which the top performing buildings are. Up in the left corner, the arrow goes up or down each week depending on how the building's performing. We were at 47 megawatts. This circle is how we think about our energy. We think about it in 3 buckets: plug load, base load, and lab load. So it used to take us 8 weeks at the end of every fiscal year to tell our executives where the power went. Now I can tell them where it's going in real time. But actually can dive into each of the plug loads, or each of the segments. So this is people. This is Tuesday through Friday. And how do I know it's Friday? Because the peak before lunch, because you see those little divots are lunch, is kind of higher before the peak after lunch. So assuming there's a lot of people that went to work from home that day. But we also can look at buildings profile. So this is City Center, so it's a 28-story building. It's a mid-rise, has a huge lab in the bottom. And so I can break down. So the top 3 boxes are static. The top right are dynamic. So as you'll see, as we stepped this building on in the morning, we got to about a 2.2 megawatt peak. And so great, that's typically how that building runs. Then we see something like this. this building's hitting a 4 megawatt peak all of a sudden. We didn't add any stuff. We didn't add people, didn't add labs. What could possibly make a building go from 2.2 megawatt peak to 4 megawatt peak in relatively a short time? Well, the only thing in my mind is that if the entire building came on at once, that's what happened. So there was a scheduling error that instead of stepping on the floors one at a time, it actually told the whole building to come on all at the same time. That inrush is what caused that peak. This could have gone on for months and months and months, if not longer, because we just don't look for it. The utility companies sometimes will catch it, but it's really when energy manager is going through a lot of files and trying to find this. We flagged this, we caught it about 3 days later. So that was pretty interesting. Now let me show you the cool stuff, because I haven't touched on the cool stuff. That screen before is all about energy management, and that's important, that's good. But this is where it gets really exciting. So this is our operational dashboard. Every building has pins on it, and these pins can be whatever I want. So what I look for is, does the building have utilities? Are the backup generators running? Do we have communications to the building? Do we have faults and alarms? And so after a power bump or a windstorm, I can go across the entire campus in about 3 to 4 minutes, not 4 hours. And I can dive into a building, and I can do this all in my pajamas in my living room. That's different. So we can see all the buildings, that's great. This is the fault count. So all fault count, and this was yesterday. So I have 5,237 active faults at yesterday, probably about 7 p.m. And so this is why I have gray hair. This is everything across our campus that's either not working as designed or where set points have made outside our standards. Great, I can see it at the top level, but we gotta go a little deeper to tell you what's going on. So we actually can go into a building. So I picked on City Center here. So you see the same static dynamic, head count, type of building, type of system, KW, but then you see these numbers on the floor, and there's numbers equates to fault. And then we can go in a little bit deeper and say, okay, we're looking at terminal unit, I have a damper stuck, I think that was stuck open. So this is great, this is a simultaneous heating and cooling. This damper gets stuck open, puts cold air in there, the space gets cold, all of a sudden the heater kicks on. This is exactly what I'm talking about. But you look at when did it happen, what's the asset, what's the priority of the space, because priority to us is very important. Then how much is it wasting in energy? And that's an annual energy waste. And you think, well, $455 a year in energy waste doesn't sound like very much to Microsoft. Doesn't sound like much to anybody. But we have 22,000 terminal units. I have 1,000 air handlers. I have hundreds of chillers. This all adds up. And buildings are living, breathing things. If they're not running as a system, then we have problems. I can actually, so this is really cool. So we can prioritize our faults, priority 1 to 5. Priority 1 is going to be critical space, life safety, maybe the CEO's office, maybe. Priority 5 is my office, just so we have a comparison there. So you can look in, priority 3 is a lab. It's not our critical lab. So you can look at all the problems we're having in a lab. You can see how much we're wasting. And do you go after $17 or do you go after $1,700? And so that really allows us to optimize our head count more effectively. This is one of the coolest graphs we have. And again, all we're doing is we're using the data we've always had to look at it in a different way. So every dot on there represents a terminal unit in a building. Buildings have hundreds of terminal units. And so top right says Red West A, air handler number 2. These are all the terminal units. So red means it's in heat mode, blue means it's in cool mode. And I can look at how is a building running as a system in one quick look. And so I can tell you who's going to be calling because they're too hot, who's going to be calling because they're too cold, damper stuck closed, stuck open, starving systems. It gives me a wealth of data that typically before we were looking at the single problem, hot, cold call, somebody complaining, versus looking at how a building is running as a system. And that's a much different approach in how we've done really optimize our buildings. And another cool thing about this, we have the data at our fingertips, all this wealth of information. And so this is one of my favorite reports. This is a performance report of an air handler. These reports took us 3-5 hours to run, but they weren't consistent. One of the manufacturer systems that looked one way, one looks a different way, but it was never consistent. This takes, whether it's independent of whichever manufacturer it is, independent of what type of design it is, it makes it very standard. And this report runs in about 2 minutes. It has about 300,000 of lines behind it. So our mechanical engineers, who used to spend 80% of their time as analysts, now actually gets to spend their time as engineers. So and it allows us to scale much quicker. So this is just a real quick view. We can look at how to work last week, last month, but more importantly, how are we working across seasons? So we really want to see how our mechanical equipment is going from spring, as it crosses the different seasons, winter to spring, summer to fall. So this is how I sold everything that we did to my boss. It did not look nearly this pretty. So we get a building in our portfolio, and we walk away from it. Now, we still do preventive maintenance, but if you think about it, say a building comes in, and for 5 years, because our retro commissioning cycle is roughly about 5 years. So we still do preventive maintenance, belt filters, all those great things, but we don't come back and really snap it up for 5 years. And then we walk away, come back 5 years, walk away, so wash, rinse, repeat. We don't go very wide, we don't go very deep. We touch about 200 assets a year, but we save about, I'd say, 250,000 energy. But again, we're not going very wide. But now if I have all that data at my fingertips, once we plug in a building, it does nothing but get optimized from that point on. And how I sold it is, hey, we used to go around the campus once every 5 years and get the whole campus in 5-year period. Now you get the whole campus in less than 1 year. And the savings that comes with that is pretty real. So for us, the punchline is it replaced our manual retro commissioning. We used to hunker down in a conference room. Don't need to do this. We can automate that, automate our reporting. The payback is less than 24 months. And oh, by the way, Washington State is the 3rd lowest energy cost state in the US. If I can make it work here, I'm pretty sure I can make it work anywhere. So just some of the capabilities. It complements our third-party commissioning. It replaced our retro commissioning. It's helping inform our CapEx plan. Which manufacturers should we use? What type of building designs? What's the most effective in how we run our buildings? And it really has changed the way how we operate our portfolio. Persistence, really important. So we can retro commission a building and think, wow, we did great. We high-five each other, and we feel really good. A technician or engineer, maybe not meaning so, can in 15 minutes undo everything we just did. And we won't catch it again for another 4.5 years. So that kind of persistence, the minute that somebody does something that's either detrimental to the building, wastes energy, we catch it then, not at some point when somebody's calling. So that's a real important part for us as well. Our metrics in how we manage and our key performance indicators. So for our facilities team, we looked at how many work orders did we complete per quarter? How many critical work orders? And there were other metrics, but it told me nothing how we were operating the building. They just weren't informing. So we actually have changed all our metrics to be much more performance-based. So one is performance, looking at work orders, how many, so what we're seeing is we run 10,000 work orders a month. And this is both preventive maintenance and reactive. The calls, I'm hot, cold, I hear noise. What we're seeing is the smart building is creating about 500 work orders a month, but we're seeing a decrease in our reactive work orders, which is exactly what had to happen and what we anticipated would happen. The middle column is really my boss's column. So my boss is a CPA by trade, so obviously he's going to be focused on consumption or dollars. Are we hitting our numbers? Are we actually seeing the meter slow down? And the third one's about employee experience, right? Are we finding that we're giving a building that's a better state, that people are more productive, they get more done? Hard to measure that, but we can look at the work order data and customer satisfaction to see, are we having an impact? Not every building in the world is a good fit for this. So this is the tiers that we came up with, and it's just a naming, the tiers, you can call it, conditions, whatever. But we came up with 1 through 4 ranking. So a tier one, maybe you have, weather data, utility data from the utility company, that's all you have. Maybe it's a warehouse in the middle of Arizona. Probably not a candidate for this, but you can still do a lot with that data. And then you add metering, okay, that's great. But when you start to get a building automation system, then it gets interesting. Then you have more data than you know what to do with. And to be really frank, buildings are becoming more intelligent every day, but they're not becoming very smart. It's not a fair fight for people who are actually managing and operating buildings. So this is the next generation of Excel. It's called Power BI. So every circle on here is a Microsoft building. The size of the circle is the annual energy consumption. So if you want to know where we're going next, we have about 10 sites around the world we actually are deploying as we talk, or as we speak now. And you can see very, very quickly of which ones we're going to. So Beijing, Hyderabad, Shanghai. In Europe, we're going to Dublin, UK, which is Timmins Valley Park. And we're doing this, and the objective is all the engineering, all the fault detection, rules writing, we're doing in Redmond. So we're complementing the local team, and at some points we're providing training on how they run the buildings. So perfect example, I send someone to China every 12 weeks. And they, there's a lot of reasons, but they tend to like to run the building in manual. And we have a very sophisticated building, very flagship building, and they take everything out of automatic, and it's wasting a ton of energy, and it degrades the building system. So we send somebody over there, they put everything back in automatic. You got it, great. Halfway over, I'm sure everything's halfway back in a manual by the time we get back to Seattle. That's not very effective. So actually, this is where the persistence in the training comes in. That I plug in our campus in China, and the minute they start taking it out of automatic, putting in manual, we catch it then. We educate, we train. So that has a lot of value in, we're doing all this remote. That's really what we're doing, is using this as a tool. And if you have strong teams and strong tools, hallelujah, we were missing the tool part. This is our operations center. So that's a picture of the people there. On the right's my little lab. And I am the luckiest guy in the world. I have a 15 million square foot lab in the latitude to try a lot of things. So it's pretty cool. And I get paid to do it. That's even better. So this is really where we do a lot of testing. We test small before we test large. We do field studies. We look at what's coming out in next generation products. We're informing the manufacturers. We actually will help the Siemens of the world of how do they make their products better, because at the end of the day, we benefit from as well. So I want you to think about how do you use IT in buildings differently. So this is a fire extinguisher. Everyone knows what that is. We have 8,500 of them across our campus. I spend tens of thousands of dollars each year, someone walking around with a punch card. And we have spaces we really don't want you to go in. So how do you look at it differently? So we actually put our fire extinguishers on the network. So a little dongle behind the dial senses when the extinguisher pressure drops or somebody removes it from the wall. The motion sensor senses if someone puts a file cabinet. So Redmond Fire Department bought off that meets NFPA standards. So now we have our fire extinguishers on the network. It's just thinking differently of IT. So really when you ask, where do you start? This is a journey. There's a lot of different solutions out there. I'm not advocating one. We ran a procurement activity, but the really key is how do you go through the journey? So, for us is have a strategy. Do you want to have dashboards in your lobbies and drive behavior change? Do you want to go deep on the engineering side? What are you trying to solve for? That's really what everyone has to kind of come up with. Build your requirements. That was super important. What do you want the technology to do? What gaps do you have? What are you trying to solve for? I never want to have software and go look for a problem. I want to have a problem and put software against it. And then we did a gap analysis across our entire global portfolio, not just on the buildings, but on the people that manage the buildings. Do they have the right skill set? Do they have the right budget? Do we have everything to do a smart building deployment, if you will? Integrate training. I probably underinvested in training initially, and I think that's one thing I probably would do a do-over on, to make sure the folks understood, hey, there's this really cool thing there. Good. Now what I do? So actually integrate it into their daily work stream is where we're at now. And then measure for success. So really to kind of recap everything, so we have 125 buildings, 59,000 housed heads. We're connected to 2 million points in aggregate 500 million data transactions every 24 hours. We're taking all the different protocols. So there are two important things with building data: encapsulation and conversion. Encapsulation is just moving data, but conversion, protocol conversion, is taking that language from French to English. Well, some systems speak Martian. So part of our pilot, the vendors had to prove that they could speak French, Italian, and Martian. So that's really important to be able to convert over. I would say what's interesting is, there it is. So 48% of the things that we're finding, we can fix it in 60 seconds or less. The other 52% we have to roll a truck. And with that, just to say thank you very much for this opportunity. This is great to be here, and I hope this was beneficial. I think we're going to do some questions and answers. So Igor,
Thanks very much for a very interesting lecture. So let's start with some questions. Right over there. Good. If you could wait for just a second to get the microphone. But we're recording. So.
The people on the other side of the camera can't hear you. That way.
Thank you. So what software are you using to build all these reports and trends and dashboards?
So we're using a company called Iconics out of Foxborough. And there's a really big conflict this week, by the way, with Foxborough, but that's okay. Us in Seattle, but the point is, we did a procurement activity. We found the best one that met our needs. But the great thing is, we thought we'd get to this moment of, the industry isn't ready yet. We're going to have to wait a couple years. But really, that's not the case. There's a lot of solutions. That's why I think knowing what you're trying to solve for and then doing a vendor procurement is the right way to go. So that's the company that we used. And so just a quick segue. This is a market transition right now. And I'm talking to a lot of my peers. The coolest one that I've seen doing something very similar is the Pentagon. So the Pentagon, they call it the reservation. I got to go into their command center. They can take the whole reservation up, spin it, turn it, do fault detection. And this is after visiting me and doing some deep dives with me. And my ego was shot. I thought, these guys are one up me, which is great. But then I thought about it, no one's ever going to see this. We're still number one. So, but it is, and I'm seeing universities having a lot of effort around this. So this really is an emerging segment that's going on right now. Oh, yeah.
Quick follow-up. Did you consider doing it yourselves? I mean, you're Microsoft.
No, Microsoft, we're the plumbing. So we don't want to get in the business of building something, competing with the OEMs. What we're doing is we're putting a software layer over everything we have, and Microsoft technology, if you will. The vendors are building on technology or Microsoft.
Gerald, thanks for a fascinating talk. Could you elaborate on your comment that Microsoft is carbon neutral? I'm curious to know, for example, did you achieve that with purchase of offsets? How much renewable energy do you have? And are any of these buildings truly zero net energy?
So no, none of our buildings are net zero. For the business that we run, we have developer type buildings. It'd be very difficult unless we made some pretty heavy investments. So how we're hitting the carbon neutrality is offsets, renewable energy certificates. We've actually have 2 PPAs in wind farms, one in Texas, one in Chicago. And I'm seeing so much momentum around Microsoft, and this is just over in a couple years of where we've always done the right things and drive efficiency. But even the fact that we're charging an internal fee for the carbon you use, so if you have buildings or labs, you actually get taxed, or I don't want to call it a tax, a fee against that. That's to drive behavior. Do you take less flights? Do you use more remote meeting? There's a lot of different tactics that's being done right now to achieve that, but a lot of it is still in the investment in RECs and offsets.
I had the sense that most of what you're talking about was more heating and cooling. I wondered how much about intelligent lighting and algorithms around that.
So lighting across our entire campus is roughly 4% of our overall load. So very small, but everyone can see it. So it is a lot of effort around, lighting right now. You're seeing lighting come out. They have sensors that look at humidity, temperature. You're seeing just a mass amount of excitement in the lighting industry and what's out there right now. So are doing several lighting pilots with some of the next generation stuff out, and it's pretty interesting because it all produces data. So the more I can connect and tie and drive, the better outcome we'll have.
Your platform, is it wired or wireless?
We have an entire building that's wireless. We're using Zigbee wireless, but most our campus, everything you're seeing up there is wired. So all our buildings are on the network. So that's one of the, you have to meet that principle, but we're expanding on our wireless right now.
Okay.
So in our Puget Sound campus, where I pay 5.5 cents a kilowatt hour, we're primarily hydro on supply. Actually, the majority of our supply is hydro. So, great sustainable story there. In California, we have on-site solar. We have geothermal in Fargo. So as these technologies are coming out, we're investing in them, and hopefully to start getting, once I'm using solar and other types of renewables in Redmond, then that's going to be the exciting for me.
So I know you talked about the software, the Iconic software. Is that also your data, all your data manipulation there? Because Microsoft has such a huge data suite, your database, everything, Iconic's handled all that?
Yeah. And there's a couple different approaches to the software. So what we're doing today is we're doing a software overlay that allows us to make informed decisions. Take this whole metadata and make it actionable. I'm not doing any command and control. I'm not looking at, say, when we're starting to reach the peak, to have a control strategy, to start changing things. Today I'm not, tomorrow I will be. But there's vendors out there that you can they'll consume the data for you and provide the engineering. We're more of the on-site model. I mean, it's still cloud-based, but we're doing the engineering ourselves.
We have another question there.
How much are you worried about security?
So
cybersecurity.
A lot. So any software that gets deployed in our building go through a heavy testing on that. So we're the second most attacked entity in the world. Federal government first, we're second. So everything we're putting in the building has to go through smoke test, black box test, all these testing to make sure that it meets ours. So the software we're using actually is running in DISA's data center. It's running at the Pentagon. So there's other, you look at who's also using it to make sure they've gone through the security checks as well. But I do agree, that's emerging. And here's a really important point. So if you look at all my peers, other companies out there, the building automation server is sitting underneath somebody's desk in their office, and the password is the word password. So letting you in a little, my forward thinking is, how do we not take all the devices, not just the building automation server, but all these devices, the Internet of Things, up into the cloud? So that's one of the things we're looking at is really, instead of having boxes that we have to maintain, not just for the building automation, but all these devices actually can be communicated cloud, feed the data, and that's really where you think of the Internet of Things starts to collide with all this. And we're going to have a lot of pilots in that, where it's getting more intense, but I think that's where the market will be going as well.
Question.
So have you published a paper of some kind that documents the details of how this process worked out and working with the vendors and collecting that data and turning it into something useful?
So yes, we do have some documents. We did a paper with Lawrence Berkeley National Lab, their EIS group, so Jessica Granderson, who's probably, I think, the lead scientist on this, and Accenture had written that. But this isn't what I started to do. At the end of the day, or really what I was focused on, I was trying to save us money. You know, I never expected to go outside of Redmond. This is not what I was trying to do. It just turned out what we were working on, it turned out to be very interesting. So there's some papers, and I'll share it with Samantha and the team. Maybe we can post it after this.
When you have power issues and need to reduce consumption by 10 or 20 or some goal %, so is that all automated in how you respond to that?
No, we have the mass, everybody grab a building and start shedding load. We don't have that, but that is, so if you think of, I think I mentioned earlier, so it snowed in Redmond about a year ago in winter pretty heavily. I think it was 6 inches. For us, that's heavy. And there were 2,000 people on campus, where there typically is 58, 59,000. Of the 2,000 people on campus, most of them work for the real estate team. The cooks were here, the janitors were here, the maintenance team were here. None of the employees were. Yet all the buildings were running as if it was a normal work day. There was no logic or sense in how do we run our portfolio. So we're looking at demand response, demand limiting. We're playing a lot with camera counters. So if the person on the 28th floor of a mid-rise crosses a camera, it's a 15th person, that starts the mechanical equipment, not because, hey, it's 7 a.m., bring everything on. So we want to get a lot more smarter in how we operate our buildings too.
Okay. Any more questions?
Earlier you commented something on internally you're charging like a tax that's incentivizing, I guess, different divisions. How is that actually done? Is it impacting like actual P&L for individual business groups?
Yeah, absolutely. That's so TJ, I wish he was here, would be able to go deep on this. But in essence, if you think of the 3 big carbon drivers for Microsoft, data centers, travel, real estate. Those are really the 3. So there's really what the 3 target. So when I travel, on the travel ticket, it says how many carbon, how much CO2e of carbon that I'm causing because of this trip. So it is that awareness, and then the P&L for the labs. If you have labs in buildings and data centers, you actually at the top level are charged against that. So there is dollars that's where the funds come from.
So could you say roughly how long does it take to take an existing building and put it online in the system?
So it depends what the jumping, that's one of those it depends questions. So how long does it take to do this? If a building's 25 years or younger, it's probably going to have or newer, it probably has a building automation systems, flowing data already. Some systems are harder to get data than others. Stuff within 10 years, I would say, are pretty relatively easy. But it's, what's your jumping off point, doing the data connection. So we were hitting about 2 buildings. Our rhythm got to about 2 buildings a week. The very first building we connected to, we fixed everything that was wrong. And then realized it'd be 100 years to get done. So we really had to, as we went through, we were learning as we were doing. This wasn't something that we had a playbook to look at. We've got one now, but there wasn't one we had before to say, in step 17, do this. But integrating the California campus, it took us a few weeks, 3 weeks, to do a huge campus. It was about 700,000 square feet, I think 7 buildings. And we did it all ourselves. We did it remotely. And our whole pilot we did with 5 people. So it's not as if you have hundreds of people to go do this, but you really do have to push. It's a tool. This is what it is. It's a tool. How do you use it? If nobody's going to touch it, then don't make the investment. But if you have it and you can embed it in the work streams and it can push, So one of the things I'm working on right now, this is very cool, is when a building has a fault, it actually will send the fault to the work order system. So I actually have buildings generating their own work orders. But we're very programmatic. We want to make sure we get it done right. I don't want a technician coming in the building and saying, I have 95,000 work orders today. Seems high. So we want to make sure that something just doesn't jam and kick a lot of work orders. So, but we actually have automated the process so you can actually push a button and it'll push a work order or the fault into a work order system. But that's our next evolution. So this is, I'll never be done. We have irrigation, we have 42 full services cafes, we have gas. Data's data to me. It doesn't make any difference where it comes from. It's just what are you going to use it for? Software is Excel. So we haven't in model, the question is, are we doing model simulations? In some of our designs we are, so we kind of knowing what are we going to end with or what are we designing to for new campuses, but we haven't got to the point. I would say everything we're doing now is getting our fundamentals buttoned up. And it's getting it buttoned up in a really big way, but it's where can we take this from now that is where the modeling, the demand response, demand limiting, but if you can't get the fundamentals right, then you have no reason to be pursuing anything else.
All right, after this great discussion, let's thank Daryl again for a
Well, thank you very much.